Good morning everyone. Today we will have a lecture on engineering mechanics. So already in previous lectures we have studied the numericals related with the engineering mechanics. So again we will have some more numericals related with the grid. In grid the different forces are acting in different directions on a grid. So again we will solve some more concept. Every problem related with the grid, it is having some different concept. So every problem is very important. Or every lecture in the engineering mechanics, it is solved with some different concept is used to solve the problems in engineering mechanics. So every lectures and every problem and every that is lecture is very important. So you have to go through every lecture so that all the concepts related with the engineering mechanics or all the concepts related with the unit number 1 will be cleared. Okay. So again I am reading the next problem related with the grid, in which the forces to be calculated and some different little bit different concept will be used in today's problem. Okay. Here first of all I will read the problem. Three forces shown in figure, shown on the grid. There are the three forces. Here first force is P force, which is acting downward. 400 Newton which is acting upward, whereas 225 Newton it is again horizontal force is acting. So what the question says, three forces shown on the grid in the given figure produces a resultant. That means all these three forces, they produces a resultant. All these three forces, they are producing a resultant force through point A. That means the resultant is passing through point A. That means here the point A it has been located. So the resultant of all the three forces will be passing through point A. That means the resultant of all these three forces will be at A. We have to find out the resultant force at point A. It is located at point A. The resultant force through point A, find the resultant and its intercept. That means we have to find out the resultant value, that is R is equals to, with x and y axis. That means we have to find out the resultant and the distance of resultant with respect to x and y axis. We have to find out the distance of resultant with respect to x and y axis. Also we have to calculate the force P. Here the unknown force is P. In previous problem there were no as unknown forces, but in this problem there is an unknown force P. So we have to find out the unknown force P, but we have to use some conditions. So what that condition is given, depending upon that conditions we will find out the force P. First of all we will find out the force P, then we will find out the resultant, and then we will find out the x and y intercept of that resultant. Okay. So one by one, step by step we will solve the problems. First we will find out the force P. Why? Because we have to find out the resultant, then we have to find out the theta, that is the angle made by the resultant, and then we will find out x and y intercept of that resultant. Okay. What about the size of one square block in this grid? So if the size is not given, in most of the problems the size will be given. In this case also the size is given. That means in horizontal direction, in x direction, what is the size of one block? It is 1 meters is the horizontal distance, whereas in vertical y direction it is 1 meters. That means the size of one block, square block, is 1 by 1 meters. That means 1 by 1 is the size of the in x and y direction, the size of a square block. What is the total size of this grid? Along x direction it is 1, 2, 3, 4, 5, 6. 6 is along x directions and 1, 2, 3, 4 along y directions. So this will be the size of the total grid. So here we will solve and we will use the concept of Variance Theorem. Okay. So every sentence, every point which has been given in the question is very important. Okay. First you have to read the question properly, you have to understand the question properly, so that the things to be calculated is more easy. Okay. Once you are and you have properly understood the question, then we can solve the problem easily. Okay. So here what is the question says, we have to, the resultant of all these three forces, it is passing through point A. It is passing through this point A. So here this A point, it has been located. So all the resultant forces, the forces they are passing to the point A. For that we have to first calculate the force P. Okay. So P, it is acting at this point, but we can assume this at this point also. By principle of transmissibility it can be transferred at this point also. Whereas 400 Newton, it is acting at this point, okay, but we can, by the principle of transmissibility, it can be transferred at this point also, okay, along the same line of actions. whereas 225 Newton, it is acting at this point, but by principle of transmissibility we can transfer at this point also. So first thing it is to be kept in mind while transferring the force by the principle of transmissibility, it should be along the same line of action. Same line of action, that means it will be along same line. It should be acting along the same line. Okay? So here 400, it is acting at the corner of this grid, but we can assume at this point also, because it is along the same line. The magnitude of this force will, or the effect of this force will be same along the starting point as well as along the starting point as well as the end point. Whereas the same is the concept of this P. The intensity of this force P, it is acting at the end of this grid, but by the principle of transmissibility we can assume at this point also. Whereas this 225, it is acting at this point, but along the same line of action we can assume this force 225 Newton along this point also. So first we will find out the force P, so that with the help of the force P we can find out the resultant and its x and y intercept. So first we will find out the force P. So we have to use the concept that the resultant of all these forces is passing through point A. What this meaning says, or what this sentence says, that means we have to use the Variance Theorem. For that, first we will find out the theta, the angle made by these forces. So 400 Newton. So 400 Newton, we can assume this angle made by this 400 Newton as theta. This as theta 1. Okay, so we are assuming this as theta 1. The angle made by this resultant is theta 1. Now 400 Newton is theta 1. Again P, always while taking the angles we have to take along x, angle made by that force along x axis. Okay, so this we can assume this as theta 2. So we are assuming this as theta 1, we are assuming this as theta 2. So we will find out theta 1 and theta 2. So I am writing down here as theta 1 and theta 2, so that the problems is more easy. So theta 1, what is the opposite side? The same concept is used. What is the opposite side? Here is the tip of this 400 Newton. So this is the opposite side. 1, 2, 3. That means opposite side blocks are 3 blocks. 1, 2, 3. What about adjacent blocks? So along x direction, adjacent blocks are 1, 2, 3, 4. That means tan of theta 1, tan of theta 1, that is equals to opposite upon adjacent, and that is equals to opposite upon adjacent. The opposite side in this case is 1, 2, 3, so 3, and adjacent side is 1, 2, 3, 4 up to this point. This is the triangle. Okay, so 4 is the adjacent side. So after converting this, theta 1 is equals to tan inverse of 3 by 4. It comes to be 36.86. You can solve with the help of the calculator also. The theta value, it comes to be 36.86. Okay. Up to this it is clear. Next we can find out theta 2 also. By the concept again we can find out the theta 2 value also. So again I am writing down the value as theta 2, tan of theta 2. Again opposite upon adjacent, so directly opposite in this case for theta 2 is 1, 2, 3, 4. 4 blocks are opposite blocks. And what about the adjacent blocks? 1, 2, 3. It is reverse of this. Previously it was 3 by 4. It is in this case is 4 by 3. So theta 2 it comes in this case is 53.13 degrees. 53.13 degrees. Okay, 53.13 degrees. Next, that sentence which has been given in this, the resultant of all the forces is passing through point A. So we have to use this sentence. The resultant is passing through point A. What this sentence says, or what this sentence, in other words, it is having the meaning. So that means movement of all the forces. Movement of all the forces at point A, that is equals to 0. Okay. What this sentence says, the resultant of all the forces is passing through point A. That means the movement of all the forces passing through point A, that is equal to 0. That is equals to 0. Okay. The summation of movement of all forces at point A, that is equals to 0. That is given in the questions. In other words, if in the questions it has been given that the resultant is passing through point at some point, that means at that point the forces will be zero. The summation of all forces will be zero. The summation of all forces will be zero. Okay. The moment of all forces at point A will be zero. Okay. So we will take the forces. This is nothing but the Variance theorem. It is as good as the Variance theorem. Variance theorem. Okay. So one by one we will resolve the forces along x and y directions. So first I am resolving this 400 Newton along x direction and y directions. So here it will be resolved along these directions. So it is theta 1 is the angle made with horizontal x-axis. So we will call this as 400 cos of theta 1. Okay. Vertical in vertical directions it will be 400 sine of theta 1. Okay. Next is force P is also inclined force. It will be resolved in two components. So we will resolve this inclined force P along x and y directions. The first force this way and at this way. Okay. As we are making this angle theta with horizontal, the horizontal component will be cos theta. Here I am writing down this as P cos of theta 2. Okay. Next is P sine of theta 2. So up to this the concept is clear. So we have resolved the forces along x and y directions. There are two inclined forces were given. 400 Newton was an inclined force and P was also an inclined force. So we have resolved these two along x and y directions. So angle made with the is horizontal. The horizontal component will be cos theta. So we have taken as 400 cos of theta 1, 400 sine of theta 1 for this first case. Second case theta 2 is there. So again while resolving this, one thing to be kept in mind. So it is towards the point. This force P is towards the point. Okay. We will resolve the same in the same sense. Okay. So it is moving right side. It is moving right side. Whereas vertical it is moving downward. Okay. So in the same sense we have to resolve the forces. Okay. It is away from the point. So we have resolved away from the point. It is towards the point. We have resolved in towards the point. Okay. So while resolving the forces, this thing it is to be kept in mind. It is whether the force is a pulling force or whether the force is a pushing force. Okay, it is towards the point or away from the point. This problem or this away and towards the point concept is also we have cleared or we have taken in assignments also. Okay. So then moment of all forces at point A is equals to 0. So one by one we will take all the moment of all the forces at point A. So we have to use the concept of principle of transmissibility while taking the moment at point A. Okay, we have to take the moment at point A. So one by one we will first we will take x component, then y component, then x component and then y component for all the forces. Okay. First force is the simple force 2 to 5. 2 to 5 is the horizontal force. We have to take the moment at point A. So we are by the principle of transmissibility we are assuming that along the same line of action it has been transferred here at this point. It is along the same line of action it has been transferred here at this point. The tip of this pen is nothing but the force. So I have assumed along the same line of action at this point. So that means it has been transferred. This force it has been assumed as and it has been transferred at this point. So 2 to 5. This arrow is this. And what is the definition of moment? Horizontal force into vertical distance, or distance and the force they are perpendicular to each other. So here is horizontal force. What about the vertical distance is 2. 1 and 1 ends 2. So this 2 to 5 multiplied by 2. What about clockwise and anti-clockwise directions? So it is moving clockwise. It is moving clockwise. So it is plus. Next 400 Newton. We are resolving this 400 Newton. Again we will take first x component then y component. So 400 cos of theta 1. Again transfer this 400 cos of theta 1 along the same line of action where we are taking the moment. We are taking the moment at point A, but here actual force is at this point. So just one block we will transfer here. We will assume to be transferred here. Okay? This force it has been transferred here. So 400 cos of theta 1. So this, it has been transferred here, 400 little bit at this point along the same line of actions. Okay, along the same line of actions. Again 400 cos of theta 1 to be rotated at A. तो कैसा रोटेट हो रहा है? Clockwise. तो 1 2 3. तो clockwise. Again it is clockwise. Plus 400. Instead of cos of theta 1, we will write down the angle. Cos of theta 1, it is 36.86 multiplied by how many blocks are there? 1 2 3. 3 blocks are there. So multiplied by 3. Yes, it is clear. Next is vertical force. 400 sine of theta 1. Again it is acting at this tip, but here the point at which we have to take the moment is at this bottom point. So again we will transfer and we will use the concept of movement, vertical force into horizontal distance, but along the same line. So we will transfer this, assume, and we will transfer at this point, okay, by principle of transmissibility. So here we are assuming this force to be transferred at this point. This vertical force is transferring at this point, and we will take the moment at A. तो कैसा move हो रहा है देखो? Clockwise. Again it is moving clockwise. So plus 400 sine of theta 1 is 36.86 multiplied by how many blocks are there after transferring this? Only one block is there. So 1. This concept is clear. Next, so we have taken horizontal force and vertical force. Next is P, the important force to be calculated by this concept. Okay, by the concept of Variance Theorem, the force which we have to calculate it. Okay, the last force P. P again horizontal component. So P cos of theta 1. Again it is acting at this point, but we are taking moment at this point A. So again along the same line of action we have to transfer, and assuming this force P will be acting at this point. At this point. ये कैसा ट्रांसफर होता है देखो, यहाँ से लेके ये टिप ऑफ माई पेन इज द फोर्स, तो यहाँ पे ट्रांसफर हो रहा है. ठीक है, ये ट्रांसफर ऐसा हो गया. ठीक है, this is transferring at this point. Again this will be it will be assumed, and the moment will be taken. So 1 2 3, how many forces are there? 3 forces is there. So P cos of theta 1 again plus clockwise. P cos of theta 2 in this case is cos of theta 2, directly I am taking the value as 53.13 degrees multiplied by how many distance is there? 1 2 3. 3 meters is the distance. Again vertical force P sine of theta 2, point is A, it is acting at the top. Okay, so by principle of transmissibility, along the same line we will transfer at this point. We are assuming and transferred this P cos sine of theta 2 as at this point. ठीक है, तो कैसा होगा, कैसा रोटेट हो रहा है? अब इट इज एंटी क्लॉकवाइज. अब देखो अबाउट ए कैसा मूव हो रहा है? एंटी क्लॉकवाइज. तो माइनस पी साइन ऑफ theta 2, it is 53.13. and how many blocks are there while transferring this? 1 2 3 4 5 blocks is there. So in this way we have taken all the forces and we have rotated all the forces at point A. We have rotated all the forces at point A, that is equals to 0. Summation of moment of all forces at point A, that is equals to 0. That is equal to 0. So you can directly with the help of the calculator you can add this concept, the 2 to 5 multiplied by 2, all this concept, and plus this plus P and minus P, again it will be added, these common terms, and it will be divided. So what is the value for this? The value for this, it comes to be P is equals to the force P, it comes to be P is equals to 750 newtons. After all additions and subtractions, the force P, it comes to be 750 newton. You should calculate all the forces. Okay, it is to be calculated by with the help of the calculator you can calculate the forces. So force P, it comes to be 750 newtons. So in this way, by the principle of transmissibility and the Variance Theorem and the concept which has been given in the questions, we have calculated the force P. The half problem, it has been solved. Next half, it has been remaining. So we have solved the problem up to this. Calculate P. So we have calculated P. Next is we have to find out x and y intercept, and we have to find out the resultant. So how to find out the resultant? So r is equals to square root of what is the formula for the resultant? So R is equals to square root of fx square and fy square. That means summation of all horizontal square and summation of all vertical square. So one by one we will take all the horizontal and vertical. So summation of first case is summation of fx, that is equals to the summation of fx all horizontal forces. First we will find out all the horizontal forces. So horizontal forces summation of fx is equals to one by one all x components. First x component is the simple force 2 to 5, it is moving right side, that is plus, so 2 to 5. Okay. What about next force 400, again it is plus 400 cos of theta 1. Theta 1 value is 36.860 plus p, but here force p is this p cos theta 2, again moving right side, so p is plus, and what is the value of that p? The p value it is nothing but 750. So p cos 30 we will directly take this as 750 cos of theta 2, 53.13. Third force is p cos of theta 2. So p we have taken as 750. This p value we have taken as 750. This p value is we have taken as 750. Cos of theta 2 we have taken as 53.13. So we have covered all the horizontal forces. Number of horizontal forces were 3, 1, 2 and 3. So we have taken as 1, 2 and 3. Just the addition is there. The summation of fx is equals to, what is the value for fx? So fx it comes to be 995 newtons. The value of horizontal force it comes to be 995 newtons. Okay. Next y component, summation of all y components. Okay. The summation of fy equal to one by one all y components. So here there is only one horizontal component was there, so we cannot take this y component. Yes, 400. So 400 upside, and sine of theta 1 is 36.86. so the sine of 36.86 degrees. Next is downward directions, minus p we have taken as, just we have calculated 750, and sine of theta 2, the sine of 53.13 degrees. So fy component it comes to be minus 360. Fy component it comes to be minus 360 newtons. Minus 360 newtons. Third is the final value for the resultant. So R is equals to, or we can write down as resultant. Therefore resultant is equals to, that is R is equal to, what is the formula for resultant? Fx square plus fy square. So all x component and all y components. The resultant value it comes to be, so R is equals to, square root of, okay. What is fx? Fx in this case is 995. So 995 square plus, and fy is negative. Okay, we can find we can take negative value, but negative square is positive. 360 square. What is the R resultant value? So the value of resultant it comes to be 1058. 58.12 Newton. The resultant value, it comes to be 105.12 newtons. So this is nothing but the value for the resultant. Then theta, angle made by the resultant. How to find out angle made by the resultant? Tan inverse of Fy by Fx. So tan inverse of summation of Fy. While finding out the theta, there is no need to use the minus sign. So directly tan inverse of Fy is 360 and Fx is 995. Therefore theta is equals to, what the value of theta it comes to be? The value of theta it comes to be 19.89 degrees. The value of theta it comes to be 19.89 degrees. So in this way we have calculated the force and the resultant. That means depending upon Fx and Fy, in which quadrant the resultant force will lie, it will lie in the fourth quadrant. Okay. So here I am drawing a small figure for the resultant. So this part is the resultant. The angle made by the resultant, just now we have calculated 19.89. So here Fx is positive. So this part is Fx. And this part is Fy is negative. So I have drawn as downward direction as negative. So this is nothing but the resultant. Next is important is we have to find out x and y intercept for this resultant. Again we have to use the that is the Variance Theorem for this. Okay. So Variance Theorem to be used in order to find out x and y intercept. To find out the x and y intercept, we have to use the Variance Theorem. Okay. So again we are using the Variance Theorem in order to find out the x and y intercept. So what the Variance Theorem says, summation of moment of all forces at point O, that is equals to resultant at that point. Okay. I am directly writing down the Variance Theorem. What the Variance Theorem says, so summation of moment of all forces at point O is equals to moment of resultant at point O. So we have to take moment of all forces at point O. So we have to take all forces at point O. Again the same concept, little bit this problem is a little bit that is more difficult. Why? Because Variance Theorem we have used twice the Variance Theorem. First we have used Variance Theorem to find out P. Next we are using the Variance Theorem in order to find out x and y intercept. Okay. So a little bit this problem is lengthy and some more concepts it has been cleared in the today's problem. So today's problem it has been a little bit more patiently you have to solve the concept or in today's problem. The moment of all forces at point O. First of all, the simple force 2 to 5, it is along the same line of actions. Horizontal force into vertical distance. So 1, 2, 3. So 2 to 5 into 3. It is moving clockwise. So it will be taken as positive. Next, horizontal force 400 cos of theta 1. So 400 cos of theta 1, but point O is this line. Okay. So this horizontal force into vertical distance. So by principle of transmissibility, we are assuming and transferring things for 400 cos of theta 1 along this line here. Okay. O, along this line. It has been transferred here. So 400 cos of theta 1 and it is moving clockwise. So plus 400 cos of theta 1, so cos of 36.86 degrees. Vertical force 400 sine of theta 1. Again O is at the bottom. The vertical force transferring at this point and movement. तो कैसा मूव हो रहा है देखो, एंटी क्लॉकवाइज. तो माइनस 400 साइन ऑफ 36.86 degree. Sorry, we have not taken the distance for this. So 400 cos of theta 1. So here the distance is for this 400 cos of theta 1 after transferring at this point. So how many distance is there about point A? 1, 2, 3, 4. So it will be multiplied with 4. What about sine? Sine, it is again transferred here to 1, 2, 3, 4, 5 multiplied by 5. Distance is very, very important. We have to multiply the force into distance. P force about point O, the horizontal. But here it is little bit at this block. So we will reverse this force at point O. यहाँ पर reverse हो गया, थोड़ा सा पीछे आ गया. Because O is at this point. So we are reversing this P cos of theta 1 in the reverse directions. Okay? Here, how many blocks are there? 1, 2, 3, 4. 4 blocks. And how it is moving? So it is moving clockwise. So plus. What is P force? P force is 750. And cos of theta 2 is 53.13. And how many distances are there? 1, 2, 3, 4. 4 is the distance. Okay. What about the vertical force? So vertical force is again, here is the vertical force. So P is sine of theta 2. So again we are transferring at point O. Okay. This. How many? 1. And it is moving clockwise. So plus. P is 750. Sine of theta 2 is 53.13. What distance is 1 meters. Distance is 1 meters. Distance to be multiplied is very, very important. Okay? So in this way we have covered all the forces. How many forces were there? 1, 2, 3, 4 and 5. So we have covered 1, 2, 3, 4 and 5. That is equals to movement of resultant at point O. So this left hand side will be same, only right hand side will be different. While finding out x intercept, we have to take the force y. We are finding out y intercept, we have to take the force x. Only these things are different. Okay. So first we will find out the x intercept. So for that we will take the force as y. The summation of Fy into x bar. Okay. Force vertical, distance horizontal. Distance vertical, force horizontal. Just this will be the reverse. But left hand side calculations will be same. Okay. So here we will take this value. So I am using different page for this. So left hand side you should calculate the left hand side value. The left hand side value, it comes to be 3115.45. 3115.45. Okay. The left hand side value of this forces, it comes to be, all this calculations, it comes to be 3155.45. That is equals to what the calculations we have equated with, Fy into x bar. So Fy in this case is, what is Fy? 360. So no need to take minus sign because downward force is there. So downward itself indicates the negative. So Fy we have taken as 360 into x bar. So this 360 divided by this, so x bar, it comes to be, simple calculations, 8.76 meters. Okay. Same way for x bar, we have calculated this value. We have equated with x bar. In order to find out the x bar, we have taken summation of Fy into x. Same way for y intercept. So same value will be there, 3155.45. That is equals to summation of Fx into y bar. Fx into y bar. So here Fx is 995 into y bar. Therefore y bar, it has been calculated, simple division is there. So y bar, it comes to be 3.17 meters. This thing is clear. So y bar, it comes to be 3.17 meters. So in this way we have calculated x bar and y bar. Okay, that means the resultant is force. It is acting somewhat beyond this grid. Why? Because x value it comes to be near about 9. 8.76 is 9. So what is the size of block along x directions? So 1, 2, 3, 4, 5, 6. It is just 6. So here somewhat here it is in along x direction. What about along y directions? So it is 3. So here it is 4. That means here somewhat here it has been acting. Okay, it is acting at this point. So in this way we can find out the x and y intercept for this force. Okay, so here in today's lectures somewhat different case was there, in which we have taken the moment at point A and we have calculated the force P, and we have calculated the resultant. We have calculated the x and y intercept of the resultant. So today's problem was very important. If anyone having doubts related with the today's problem, they can ask. So here we will end this today's lectures. Thank you everyone. Thank you.